morning friends, last we discussed about the first illustration of chapter 13 nuclei. We find out the density of iron atom, right? By finding the radius of iron atom and then using the equation of the density mass per volume. Okay. Now the second illustration, calculate the energy equivalent of 1 gram of substance. We have to find out the energy equivalent of 1 gram of substance. So we know that the relation between the mass energy E is equal to mc square. Here the mass of the substance is given, the m is equal to 1 gram. Therefore, m is equal to 1 gram is equal to 10 raised to minus 3 kg. C is the velocity of light in vacuum. Therefore, C is equal to 3 into 10 raised to 8 meter per second. From Einstein's mass energy relation equation, E is equal to mc square. Substitute the value m 10 raised to minus 3 into velocity of light in vacuum 3 into 10 raised to 8 whole square. Therefore, 10 raised to minus 3 into square of 3 9 into 10 raised to 16. Therefore, 9 into 10 raised to 30 joule. That is the energy equivalent of 1 gram of substance. Here only the question is that to find out the energy equivalent of 1 gram of substance, that is not mentioned. We have to find out joule point MeV. Suppose this question is asked, find the energy in MeV. Equivalent of 1 gram of substance, at that time, whatever the energy obtained in joule divided by 1.6 into 10 raised to minus 19. Right? So we obtain directly in electron volt and then we can convert into MeV. Clear? Okay. After that, so this type of the question, illustration 13.2 is important for MCQ type question. Now 13.3. That is also important for 3 marks question. Find the energy equivalent of 1 atomic mass unit in joule and also in MeV. Using this, express the mass defect of oxygen 816 in MeV per c square. C is not coulomb here, keep in mind that. That is the velocity of light in vacuum. Clear? Therefore, first we know that 1 atomic mass unit is equal to 1.6605 into 10 raised to minus 27. That much kg. That is the relation between atomic mass unit and kg. Okay, 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. Now, first we find out the energy equivalent to 1 atomic mass unit using this equation. E is equal to mc square. M is already we have 1 atomic mass unit. 1 atomic mass unit is equal to that much kg, 1.6605 into 10 raised to minus 27 into velocity of light 3 into 10 raised to 8 whole square. Thus we obtain 14.93 into 10 raised to minus 11. That much joule. Or in other words, we can write in that form 1.493 into 10 raised to minus 10 joule. That is the energy in joule. Now we convert this energy in mega electron volt. So first we convert into the electron volt and then in MeV. Therefore, E in electron volt is equal to 1.493 into 10 raised to minus 10 upon 1.602 into 10 raised to minus 19. So thus we obtain 0.9315 into 10 raised to 9. That much electron volt. Just make it 0.9315. 9315 into 10 raised to 9 electron volt. Now, that is in electron volt, convert into the MeV. Therefore, 10 raised to 6 is taken as M. Therefore, 10 raised to 3 is remaining. This 10 raised to 3 is multiplied this. Therefore, 931.5 MeV. That is the energy in mega electron volt. This energy is equivalent of 1 atomic mass unit. Right? Okay. Now, this energy is also written as 1 atomic mass unit is equal to E upon C square. E upon C square. Therefore, 931.5 MeV upon C square. MeV upon C square. Okay. Now we are interested to find out the mass defect of oxygen 816 in MeV per C square. Okay. Therefore, in oxygen 816, 8 proton and 8 neutrons. Eight proton and 8 neutron are present. Therefore, mass defect of oxygen 816 is delta M is equal to 8 mass of the proton plus 8 mass of neutron minus mass of oxygen. Mass of oxygen. Right? Mass of the oxygen is 16 is given. That is the practical value. Right? Therefore, mass of the proton MP is equal to 1.00727 atomic mass unit. Mass of the one neutron is 1.00866 atomic mass unit. And mass of oxygen atom MO is 15.99035 atomic mass unit. Substitute all this value. Therefore, 8 into mass of proton 1.00727 plus 8 into 1.00866 minus mass of oxygen 15.99035. Thus we obtain the mass defect is, so first we multiply this thing. The mass of the 8 proton is 8.05816 minus mass of the 8 neutron 8.06928 minus mass of oxygen, that is the 15.99035. Thus we obtain the mass defect is 0.13691 atomic mass unit. Right? But we know that 1 atomic mass unit is equal to 931.5 MeV per C square. Therefore, mass defect delta M is equal to 0.13691 into 931.5 MeV per c square. Therefore, 127.5 MeV per c square. There is the mass defect of oxygen. So in this numerical, the numerical value are much more. Again, first we have to find out the energy equivalent to 1 atomic mass unit in joule and also mega electron volt. For that purpose, we have the equation is equal to mc square. 1 atomic mass unit is equal to 1.6605 to 10 raised to minus 27 kg, and 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. Now E is equal to mc square. Substitute this value of 1 atomic mass unit, 1.6605 into 10 raised to minus 27 into c square. C is equal to 3 into 10 raised to 8. Thus we obtain the E is equal to 1.493 into 10 raised to minus 10 joule. That is the energy equivalent to the 1 atomic mass unit in joule. To convert into mega electron volt MeV, we have to divide this value in joule by 1.602 into 10 raised to minus 19. After dividing, we obtain 0.9315 into 10 raised to 9 in electron volt. But we require in mega electron volt. Therefore, 931.5 MeV. There is the energy equivalent to the 1 atomic mass unit in MeV. So keep in mind this relation, that is the most important, 1 atomic mass unit. Now, therefore, 1 atomic mass unit is equal to E upon c square. Because the E is equal to mc square, that is the M. 1 atomic mass unit is equal to E upon c square. Therefore, 931.5 MeV per c square. Using this expression, we had to find out the mass defect of oxygen in MeV per c square. For that purpose, in oxygen atom A16, 8 proton and 8 neutron are present. Mass of the one proton in atomic mass unit is 1.00727, and mass of the neutron 1.00866 atomic mass unit, and mass of oxygen, experimental value of mass of oxygen 15.99035 atomic mass unit. We know the equation of the mass defect, delta M is equal to 8 times mass of proton, because the 8 proton are present, plus mass of 8 neutron. From this, subtract the mass of the oxygen. So here we substituted 8 into mass of proton plus 8 into mass of neutron minus mass of oxygen. We obtain this value 0.13691 atomic mass unit. That is the mass defect for oxygen in atomic mass unit. But we require this mass defect in MeV per c square. For that purpose, we have the equation 1 atomic mass unit is equal to 931.5 MeV upon c square. Now for oxygen, we obtain the mass defect delta M is equal to 0.13691 atomic mass unit. Therefore, mass defect of oxygen is equal to 0.13691 into 1 atomic mass unit is equal to 931.5 MeV per c square. We have to multiply this. Therefore, we obtain 127.5 MeV per c square. Actually, that is the binding energy. That is the binding energy. To separate the proton and neutron from the oxygen nuclei, we require 127.5 MeV energy to separate the proton and neutron. Therefore, binding energy oxygen 816 is Bl is equal to delta M into C square. Delta M already be found in this way, 127.5 MeV per C square into C square. C square cancel, therefore 127.5 MeV. That is the binding energy of oxygen. Okay. Now after that, the 13.4, the half-life of uranium 92 to 38 undergoing the alpha decay is 4.5 to 10⁻⁹ year. What is the activity of 1 gram sample of uranium 92 to 38? That is the most important numerical. That is the most important numerical. Now here the half-life is given. Therefore half-life, that means the tau half is equal to 4.5 into 10⁻⁹ year. Now we know that the 1 year is equal to 316 into 10⁻⁷ second. 10⁷ second. Therefore, first we have to convert the tau half into second. Therefore, tau half is equal to 4.5 into 10⁻⁹ into 1 year is equal to 3.16 into 10⁻⁷. 3.16. Therefore, we obtain 1.422 into 10⁻27. 27 seconds. So that is the tau half in second. Now we have to find out what is the activity of 1 gram sample of uranium 92 to 38. That means first we have to find out the number of atoms in 1 gram of uranium. For that purpose, atomic mass of uranium 92 to 38 is 238 gram. 238 gram. Therefore, in 238 gram of uranium, numbers of atoms is equal to, you will get your number in A. Therefore, in 1 gram of uranium, numbers of atoms N we have to find out. Therefore, N is equal to Na upon 238. 238. Na. What is the value of Na? 6.025 into 10⁻23 upon 238 upon 238 gram. Therefore, 25.3 into 10⁻20 atoms per gram. Atoms per gram. Right? Okay. After finding the number of atoms in 1 gram uranium, we have to find out the activity of uranium. Therefore, the activity of uranium 92 to 38 is R is equal to lambda N. Lambda is the decay constant. Decay constant is 0.693 upon tau half into N. N is the number of atoms in 1 gram uranium. Therefore, 0.693 tau half already be found in second. 1.422 into 10⁻27 into N 25.3 into 10⁻20 into 10 raised to 20. So we obtain 1.23 into 10 raised to minus 4 disintegration per second. That means the Becquerel. That is the Becquerel. Already we know the definition of the Becquerel. If the one nuclei is disintegrated in second, so the activity of this substance is known as the 1 Becquerel. Right? So there is the activity of 1 gram of uranium. Again, the half-life of uranium-92-238 undergoing the alpha decay is 1.4.5 to 10 is to 9 here. So tau half is given. First we convert into the second. Therefore 4.5 to 10 is to 9 into 3.16 into 10 is to 7. Thus we obtain the tau half in second is 1.422 into 10 is to 27 second. Now we have to find out the activity of 1 gram uranium. Therefore, first we have to find out the number of atoms in 1 gram uranium. The atomic mass of uranium is 238 grams. There is the mass of 1 mole. In 1 mole uranium, the number of atoms is equal to Avogadro number. In short, in 238 grams, that means in 1 mole of uranium, numbers of atoms is equal to Avogadro number Na. Therefore, in 1 gram of uranium, the numbers of atoms is how much? N. Therefore, N is equal to Avogadro number divided by 238 gram. Avogadro number is 6.025 into 10 raised to 23 divided by 238. Thus, we obtain the number of atoms in 1 gram uranium is 25.3 into 10 raised to 20 atoms per gram. Now, the activity of uranium-92-238 is R is equal to lambda n. Lambda is the decay constant. Here lambda not given, but the tau half is given. Therefore, the relation between lambda and tau half is 0.693 upon tau half into N. That means that instead of lambda, we substitute this 0.693 upon tau half into N. And we substitute all this value, we obtain the activity of 1 gram of uranium 1.23 into 10 raised to minus 4 becquerel. Right? Okay. Okay, now next numerical is 13.5 of illustration. While the 13.6 and 13.7 are cancelled for the board exam. Okay. Now there is the last numerical of illustration 13.5. Now the question is that lithium has a half-life of 12.5 years. Undergoing the beta decay, what fraction of the sample of pure titanium will remain undecayed after 25 years? Here the half-life of tritium is given. Undergoing for the beta decay. After the 25 years, whatever the part of the tritium is undecayed. Right? For that purpose, first the half-life is given. Tau half is equal to 12.5 years. Total time T is given as 25 years. Now, keep in mind this equation, hence N is equal to total time upon tau half. Total time upon tau half. Total time is 25 years upon 12.5. That means we obtain the N is equal to 2. Value of the N is equal to 2. And now, the fraction of the tritium remain on decay is remain on decay is N upon N0. N0 is the initial pure tritium. N is after the 25 year, whatever the part is on decay, right, is equal to 1 upon 2 is 2n. What is the value of small n we found? 1 upon 2 is to 2. It means the 1/4. 1/4 part of tritium is remain on decay after the 25 years. So keep in mind these two equations. There is the very important for objective type question and this type of the numerical. To find out the remaining part of the undecay or whatever the fraction is decay in given time interval. So very easy, total time upon tau half, we find out the value of n and the part remaining on decay is n upon n0 is equal to 1 upon 2 is to n. Right? Therefore 1/4 part of tritium is remain on decay. Clear? Therefore 1/4 part of tritium remain on decay. Clear? So very easy, and also this numerical, this equation we not studied in theory portion. For that purpose, keep in mind these two equations. That is the most important equation. That is helpful in MCQ type question and also numerical. While the 13.6 and 13.7 are cancelled for board exam. Okay. Now next, the numerical of exercise. In exercise 13.6, 13.12, 13.14 and 13.22 of exercise, and also all numerical of additional exercise are cancelled. Clear? Okay. Out of 22, we have to calculate the 18 numerical of exercise. So first numerical of exercise 13.1, two stable isotope of lithium, lithium 36 and lithium 37, have the respective abundances of 7.5% and 92.5%. These isotopes have masses 6.01512 atomic mass unit of lithium 36 and 7.01600 atomic mass unit of lithium 37 respectively. Find the atomic mass of lithium. Find the atomic mass of lithium. So for that purpose we have the equation atomic mass of the lithium is equal to average mass of isotope, its isotopes. Therefore atomic mass of lithium is equal to average mass of its isotopes. Here two isotopes are given having the different percentage 7.5 and 92.5, and we have to find out the atomic mass of lithium. Therefore lithium 36 has the percentage is 7.5 and the mass is given as 6.01512. Therefore 6.01512 atomic mass unit into what is the percentage 7.5 plus second isotope having the percentage is 92.5, atomic mass is 7.01600. So 7.01600 into 92.5 divided by total mass of both isotope 92. Total percentage 7.5 plus 92.5. So as is simplified, therefore we obtain 45.1134 plus 648.98 divided by 100. Thus we obtain 694.093 atomic mass unit upon 100. Therefore, 6.941 atomic mass unit, that is the atomic mass unit of lithium. Atomic mass of lithium. That is our first answer. Again, for the lithium, has the two stable isotope, lithium-36 and lithium-37. The percentage or the abundances of this isotope to form the lithium atom are 7.5 and 92.5 respectively. Having their masses are 6.01512 atomic mass unit and 7.01600 atomic mass unit. Find the atomic mass of lithium. So we know the equation, atomic mass of lithium is equal to average mass of its isotopes. Therefore, atomic mass of lithium is equal to first fraction, the first isotope B, lithium, 5, lithium-36, has the mass 6.01512, percentage is 7.5, plus second isotope, lithium-37, mass is 7.01600, plus its percentage is 92.5, divided by sum of the percentage is 7.5 plus 92.5. So as we simplify, we obtain the atomic mass of lithium is this. Now the B portion, section B, it also same as this, but here we have to find out the evidences of the isotope of boron. Okay. The second part, boron has the two stable isotopes, boron 510 and boron 511. Their respective masses are 10.01294 atomic mass unit and 11.00931 atomic mass unit. And the atomic mass of the boron is 10.811 atomic mass unit. Find the evidences of the boron 510 and boron 511. Clear? For that purpose, we need to assume that suppose the evidence of the boron 510 is X percentage and remaining percentage is of 511. For that purpose, if evidences of boron 510 is X percentage and of boron 511 is 100 minus X percentage. 100 minus X percentage. Therefore, atomic mass of boron is equal to average mass of its isotopes. Therefore, directly I substitute the value 10.811 atomic mass unit of boron is equal to. Now the atomic mass of boron 510 is given 10.01294 multiplied by X percentage plus boron 511 has the mass is 11.00931 into 100 minus X divided by 100, because the X plus 100 minus X cancel, therefore 100. Take this 100 this side, therefore 1081.1. Now multiply with X, there is the X time. Here first multiply with 100 minus X. Therefore X we take the common, therefore 10.01294, right? minus multiplication with this 11.00931 amps. Right? And now multiply with 100 plus 1100.931. This 100 is taken this side. Our aim is to find out the x. Therefore, we take the 1081 in this side and this part in this side. Therefore, this negative becomes positive, this becomes the negative. Therefore, 11.00931 minus 10.01294 times x is equal to 1100.931 minus this 1081.1. 1081.1. So simplification of this is 0.99637x is equal to 19.831. Therefore, x is equal to 19.90%. Is the abundance of board 510. Therefore, abundance of board 511 is 100 minus x is equal to 80.10%. 80.10%. So this way we can find out what is the percentage of board 510 and board 511 in board. Having the atomic mass is 10.811 atomic mass unit. Clear it? So that is very easy. Only keep in mind the equation. Atomic mass of the any given atom is equal to average mass of its isotopes. Clear it?